All right, so welcome everyone. We're excited to be hosting the second Project Blue at Home webinar lecture series. Today we're joined by Megan Cook. She's a deep sea explorer and manager of education partnerships and programs at Ocean Exploration Trust. They've been a partner with AltaSea for the last several years. Yeah, Nautilus, so their boat, that's AltaSea is their home port. So we're really excited to have this, and Megan, you can take it away.
Thanks so much. Hi, everybody. Thank you for coming and being part of this chat today. I'm so excited to share with you a little bit about my work at Ocean Exploration Trust. I'm coming up on my 8th year of exploration, working with this team, exploring parts of the world that are totally unknown and unexplored in the deep sea. So picking some of my favorite discoveries was incredibly challenging for me today, but I want to share a few that are really special and near and dear to my heart. And I want to answer your questions all about the deep sea, about how we explore it, about how you can do the kind of work that I do and work with the amazing professionals that I work with from all over the world. So if you have questions today, send them in on the chat. And they'll be monitored, and we'll get to maybe a few as we go through, but definitely a bunch at the end. So that is the plan. Also, thanks for participating in the Project Blue at Home series with our partners, AltaSea. We hope you've been enjoying the different challenges that have come up each week. And there is a Nautilus and ROV Hercules themed challenge for this week. So I hope you'll consider putting in some art after getting a little inspiration from this chat. So let me share my screen, because one of the things I love the most about working in the deep sea is that it is just full of incredible things that I had never seen before in my life. I have the privilege of being a deep sea explorer now and working on a team where we combine scientists and engineers. I am a scientist by training. I studied specifically coral reefs and invasive species, which you will not see a lot of in this presentation. But I hope that one of the things you might draw out of this, and one of the things that is most exciting to me about getting to do this work, is that I'm constantly learning. My background as a scientist has trained me well to be curious about the world, and now I get to go be curious about one of, in my opinion, the most spectacular landscapes on all of Earth, which is the soggy, salty parts of Earth. So I'm going to share some pictures with you, and I'll be back in just a little bit. All right, I hope you are all seeing a big picture of the ship. This is exploration vessel Nautilus. She is 211 feet long, and she is one of the places where I go to work. This is our ship that moves all over the world and is home to up to 50 explorers at a time all together there. Throughout and at the end, we'll certainly show you lots of ways that you can stay involved and get involved with us. But I want to introduce to you this big, stunning fact right out of the gate. The ocean is 95% unexplored. But our team is working on that, along with a lot of talented partners. The parts of the ocean that are still unexplored are the parts that are far away from shore, that are deep, that are dark, and you generally can't put on like a mask and snorkel and fins and go to those places that are truly uncharacterized and unexplored. So what we do breaks down into 3 big categories. One of those is go places that are unexplored. But the second one is how we do it, and that's develop new technology and new tools that allow us to go to these places deep in the oceans and onto the seafloor in order to make discoveries like that. And the third part of our mission is the part that's most near and dear to my heart, and that is sharing everything we find and everything we discover with the whole world. Every picture you're going to see in this presentation and every video is available to you on Nautilus Live. So if you see something you really like, you can continue exploring and checking it out yourself. Now, I want to share with you a little story about me before we get started. I did not grow up anywhere near the ocean. I grew up in Idaho, in the desert. And so the ocean was not really a big part of my life until much later on, really, until high school, until I went away to college and decided that I wanted to study science. So how the ocean came into my life was through fantastic teachers. So thank you to any educators who are joining us today and If you are a learner yourself, please go thank an educator who's helped you along the way, but also through reading. You know, the ocean could come alive for me in storybooks, and having a library card meant that I got to explore the world, even from sitting in the desert. So no matter where you live right now, where you're tuning in from, what your path has been, just know that you can go anywhere that you want. Certainly, my journey has taken me around the world with our team and to some amazing landscapes. These little dots are the spots where our team has explored around the world. Since 2009, we've owned and operated that ship and taken it from the Black Sea, the Mediterranean, the Aegean, across the Atlantic Ocean, into the Caribbean, and all throughout the Gulf of Mexico. And then in the last several years, we crossed through the Panama Canal and have been exploring as far north, almost to Alaska in Canada, and as far south as Ecuador, and now, well, even farther south out in the Central Pacific into Samoa and American Samoa. So each of these dots are a separate expedition where we set off with the unique team of scientists and engineers and technology specialists, educators and students to further expand what we know about Earth. So each one of these expeditions has different questions, different goals. It means we get to work with all kinds of different scientists and perspectives and put those together in one place. Now, each one of those pins is like a multitude of other pins of discoveries. So this is where I mean it was really difficult for me to comb through and try and figure out a little bit about which ones I wanted to show you. And in 22 expeditions that I personally have been on Nautilus, what were some of my favorite discoveries, along with the many, many more that I've helped support from shore. So here's my best take at that. Before we get to a highlight, I want to talk with you a little about telepresence, and which is how I'm talking to you right now. And it's also how we're able to make these discoveries on the seafloor. Telepresence is just a big word to talk about the technology suite that we bring together and bring to bear to solve this problem that we are going very deep in the ocean. We are going where it is dark, and there's only space for a certain number of people on the ship. There's space for no one on the machines that go down deep. We use remotely operated, so no people inside vehicles. But we also want the minds of the world and the experts for all their different topics to be able to contribute. So this combination of technology we call telepresence is how we make that happen. So starting on the lower left, ROV Hercules, remotely operated vehicle Hercules, and ROV Argus. Those are two robots we send down deep into the ocean. I'll get back to them a little more in a moment and give you a better picture. They're connected together and they're connected to the ship. Through that cable, that tether that connects them, we send them commands and controls, and they bring back high resolution video, pictures, and information, scientific information like the temperature, the salinity of the water around, as well as the navigation. Where are they? And how far are they away from the ship? All that information comes back up through the tether to our team on Nautilus. We beam it to space through a stabilized satellite. We rent a satellite half the year to do that. It comes down to a satellite ground station, and like fiber optic internet you may have where you live, it goes racing at the speed of light through those national networks and international networks sent from the Inner Space Center, which is our just communications hub to send it out to the world. So anything that ROV Hercules sees on the seafloor can be seen by anyone around the world who has an internet connection through this pathway. And that's how all the photos that are captured here that I'll share with you were collected, and how you can tune in and be part of exploration that continues to happen on the seafloor all around the world in real time. You don't have to wait for someone like me to tell you what the discoveries are. You can make those discoveries yourself. So this is the ship exploration vessel Nautilus, home to about 50 people at a time. We work 24 hours a day on Nautilus. So we divide up into watch teams. Those are kind of like shifts. And so we can rotate each other in and out of the control rooms, on the back deck, doing whatever work needs to happen in order to make our team be very efficient. Like I mentioned, 95% of the ocean is still unexplored. We have a lot of work to do, and we want to do as much as we can every time that we go to sea. On this vessel, we have a couple ROVs. ROVs stands for remotely operated vehicle. One more time, that's a mouthful, so we call them ROVs, and we also give them names. ROV Hercules is in the front with the yellow top, and ROV Argus is in the back. Special sneak preview, we have also built a couple new ROVs. So if you're a longtime Nautilus fan, you may see a couple new ROVs in the mix this year, and you can learn more about those on nautiluslive.org. Now these ROVs are equipped to do all that we'd want to do on the seafloor. Collect samples. There's 2 manipulator arms in the front with interchangeable types of hands and jaws to pick up rocks or to pick up biological specimens. There's a vacuum cleaner, we call the suction sampler there, so you can slurp up things that would have a bad day if you grabbed them with a metal claw, or pick up things like sediment or small pebbles. We can collect mud samples. We can collect just temperature and salinity, what we call physical oceanography information about the seafloor. But we also collect video. It's one of our most important types of data, is just seeing what's down there and then collecting the scientific expertise to be able to name and identify those things. What kind of animals are there? What kind of rocks are there? What kind of habitats do we see? For most of the deep sea, it's very hard to say things like, how are they changing over time? Because we're seeing things for the very, very first time. Exploration is really the step that comes ahead of research. Once you know what's there, or the patterns that you start to observe by seeing something new, then you can start to ask questions like, how is it changing? Why does it do that? And those are really good science questions that can come after our team of explorers, or maybe revisit a place and come back to it again. For scale, I just love these ROVs. And I always think the scale is kind of hard to tell from this picture. Just for perspective, Hercules is about the size of a Jeep, a small Jeep. When I stand up there next to it, I am shorter than it. It's about 8 feet tall and about 5.5 feet wide and about 9 feet long, sort of that size. ROV Hercules is, many people are surprised to learn that Hercules is actually turning 19 this year. It was originally designed in the early 2000s, but you can change in and out different types of systems and tools each time you pick up a different mission. So maybe we want to take off this kind of scientific sampler or tool that a researcher brings, and we want to exchange it with something else. So that means this ROV isn't exactly like one machine altogether. It's a combination of a lot of different machines. And each one of those is rated for how deep you want to go. These ROVs will take us down to 4,000 meters, diving as a team like this. 4,000 meters is 13,000 feet. If you like to measure in football fields, it is 40 football fields. So, you know, whatever measurement you like there, either way, it is very deep. We are talking way deeper than diving could take you. For reference, 40 meters instead of 400 meters is the limit for scientific scuba diving. That helps us get to about 50% of the world's ocean. And that's where I'm going to share some of these discoveries that I just love from depths like that around the world. So my first favorite that I wanted to share with you has nothing to do with coral reefs or invasive species like I was trained. One of the most amazing discoveries that I love to see is when we reveal the shape of the Earth for the very first time. So one of those discoveries I want to share is seafloor mapping and the landscapes we continue to just peel back the unknown and reveal on Earth. What you're looking at are 2 islands, the Socorro Islands in Mexico. And if you have the bright rainbow seafloor all around, and then you have the dark kind of like soft focus, general focus of the background. If you were to take your phone, Google Maps, whatever app you like, and zoom in on the ocean, it looks like, you know, if you're looking at a whole ocean, it looks like you can see a lot of detail. But as you start to zoom in and start to zoom in, you really lose a lot of that crisp, clear detail. And that's because our oceans are still not mapped with modern resolution. We are missing lots of features in the ocean just because we have sort of this wet blanket approach to what the seafloor looks like. We measure things from space. We measure the depths from space through a system where you can take hundreds of thousands of measurements of the sea surface and sort of interpolate, sort of guess what the sea level below, what the seafloor actually looks like. But satellites can't shoot beams that can penetrate through water, so it's very difficult to get anything of a high resolution. So that kind of general landscape is the fuzzy background. When we go seafloor mapping, we're able to use a multi-beam mapping sonar that looks like this. It's a sound pulse sent down from the ship. It goes out in a fan shape, and this operates just like an echo. When you send the sound pulse out, you can start counting and listening for that sound pulse to bounce off the seafloor and come back. Now, if you know how fast the sound is moving, this is just a simple math question here, how far it goes, how long it comes back, you can figure out the total distance that it's traveled or how deep the ocean is in that area. Multi-beam mapping sonars help us reveal incredible landscapes on the planet. And this is one of my favorite discoveries because I had absolutely no idea that some of the shapes of Earth looked like this. It's really easy for me to look at mountains and hills and be impressed by their size and their scale. But once they're underwater, they're very difficult to see. But every landscape you know from Earth, mountains, hills, canyons, big open plains, all of those landscapes are underwater as well in the geology. Here's a couple more favorites from seafloor mapping for me. This is a rift zone, which is absolutely amazing that this is the shape of the Earth. I would love to go hiking here and go walking through this landscape. This is a result of tectonic action where when plates are moving apart, they don't always move exactly strictly apart. They can get sort of bound up and be moving side by side. And when that pressure builds from moving side by side, rocks and the actual centers of the plate can end up with these tears and rifts in them from the different rock boundaries interacting in that way, older rock with newer rock, or just the pressure within that rock. So you can end up getting these sort of like stretches and tears within boundaries of rocks that look very regular like this, like stripes on this image. And I didn't know anything about this. I didn't learn about this in school. When I got on Nautilus, I was constantly amazed by the brand new things that would come across my mind and across the minds of folks around me. And one of the best things about my job is that you get to learn from experts all around you. Here's a couple more incredible landscapes that I love from seafloor mapping. These on the lower right are the moonless seamount, a mountain underwater, from the Moonless Mountain Chain, which is about 1,000 miles west of the west coast of the US, but also about 1,000 miles northeast of Hawaii, just right out in the Central Pacific. And previously, when you had gone over that kind of like soft focus, not really detailed look, neither of these features stood out. And when we used our multi-beam mapping sonar and mapped over these areas, sort of like mowing the lawn, you just go and cover an area going back and forth mapping, out pop these amazing landscapes. This is called a geo on the upper left. It is a seamount with a flat top, and those can be formed by coral reefs if this mountain was above the surface of the ocean at one point and is now sinking back into the crust of the Earth. Absolutely incredible things. So seafloor mapping is and continues to be and will always be one of my favorite discoveries. I also think these are just beautiful as images and as data, but also just to imagine these different places on Earth and to put myself, down there taking a stroll. For reference, the image on the right, these are scaled differently, but the image on the right, the purple blue parts are deeper and they're about 5,000 meters deep. And the red parts, the tippy tops of those little hills, are about 3,000 meters deep. So you're seeing a really drastic landscape. It's just hidden from us by being underwater. One of my next favorite discoveries has to be hydrothermal vents. I've had the chance working with the Nautilus team to visit these incredible landscapes. These are geysers, hot water vents underwater, underneath the ocean. And these also are generated by a geologic foundation. So when two plates do move apart from one another, it tears the rock and cracks can fill with water, and water can move down and become heated by that energy within the Earth. As it's heated, it rises and dissolves some of the rock around it. And out comes this black smoke. Now, this isn't actually smoke. It's super hot water with dissolved minerals in it. But when I say super hot, I'm talking 600 plus degrees Fahrenheit, and they can get much hotter than this particular chimney that we're sitting on here. These are an stunning landscape. What I like about them is they seem so remote and so foreign, and yet they are covered in life. Everything that you see here with the kind of shagginess on it, those are all worms, and they're worms living off of and digesting some of the minerals and chemicals rising out of the earth. Totally cut off from the sunlight, just an amazing landscape. I hope that video came through for you. If it was choppy, we can go back to pictures here. One of the other things why these are my favorite is, I don't know about you, I have certainly been asked the question, if you could have a superpower, what kind of superpower would you want? It's a tough question, you gotta think about it for a while. But I think being able to fly would be one of the coolest superpowers. And I've always thought that when I've lived in big cities or been even in a forest and imagined how cool it might be to fly in between the buildings or fly in between the trees. And exploring hydrothermal vents felt like that for me. This is a view from ROV Hercules in front of these big spires. These can be tens of meters, hundreds of meters off the surface with these big chimney vents all around. And our pilots, our engineers are expertly just weaving and flying the ROV in between these pillars and getting these remarkable views of this landscape in total darkness all around, right? You only have the light you bring with your flashlight. I love these landscapes because they just inspire me. I think they kind of look like Dr. Seuss, or like they're made and poured from wax, because as that dark, hot, dissolved mineral water, the black smoke of black smokers cools, out come those minerals, and they start to precipitate down, or that means fall out of the water, and build up these structures all around. So these things are constantly growing, toppling, and so it is a very alive, very dynamic, ever-changing, and remarkable landscape to see. Something that feels so alien, I guess you can say that, but it is very much of Earth. Like, this is a part of Earth as much as we are a part of Earth. We just haven't spent that much time, or most people haven't spent that much time checking it out. So this will always, always, always be one of my favorite discoveries. They were discovered in the 1970s, and we continue to get to go back to these sites and continue to understand and ask more questions and research more about them. So these photos are all from the Endeavour hydrothermal vent field up off the coast of British Columbia, Canada. Next favorite discovery. What would a talk about favorite discoveries be without a shipwreck? This is the shipwreck of USS Independence. She was a World War II aircraft carrier, and she was intentionally sunk after the war. In 2016, we had the real pleasure of and privilege to go back and survey this ship for the first time since she had gone down 65 years before. Now, USS Independence had a really storied career. She was an important part of the US World War II war effort. And she was an important part of history as part of Operations Crossroads. After the war, she was taken to Bikini Atoll for the atomic tests, and she had not one, but 2 atomic bombs dropped onto this ship and an entire array of other ships. She did not sink after that effort, and was hauled back to use as kind of a study site. How was the ship impacted? How had it not sunk? To better understand more. After a period of years, about a decade of using her as a research site, she had ended up using up the use case that the Navy had for her. And it was also during the time of the Cold War, when they didn't really want a lot of US ships hanging around. So in 1951, the ship was hauled offshore underneath the Golden Gate of San Francisco. And this is the pre-GPS days, so somewhere off the Golden Gate, she was sunk into deep water. Now, one of the things I think is the most powerful about Independence, and why I loved being a part of this expedition, not only for just the awe and how breathtaking it was to see something this big underwater, and to realize that we were writing a new chapter and encountering a new time in independence, her story. But it's also a real opportunity to talk about how we treat the ocean very, very differently than we have in the past. There was a time where if you wanted something to go away, you would take it out into the ocean and sink it. I think you all know, and I certainly hope you all know, and from your great submissions from the Project Blue art contest, seeing your inspiring visions of the ocean, you know that that's not the way we interact with our planet anymore. And we know better, so now we do better. So Independence had been sunk for 65 years. She was rediscovered by some of our partners, the NOAA Office of Ocean Exploration and Research and Boeing. They were testing an underwater mapping system and came across a target that looked an awful lot like the right dimensions and size for Independence. That's the image up in the upper left. So we worked together with a lot of partners. Nobody could work on a ship by themselves. Nobody could do work at sea without other people who also support and collaborate on these kinds of missions. So we had the great opportunity to take the target and sort of the tip from those partners, and then go and take a team of archaeologists to do an investigation and a proper documentation to continue this story. Another part that I love about Independence is just picturing this new life, this brand new chapter for Independence. Since she has been on the seafloor for 65 years, she is now covered with all kinds of life, as you could see in that picture. These things that look sort of like baskets, those are called glass sponges. It is an animal, might surprise some of you, it's a colonial animal. And rather than kind of like calcium that we make our skeleton out of, or many skeletons and bones that you might be familiar with, hexactinolid sponges make a skeleton out of silica. So their bodies actually are made of glass, surrounded by tissue. Sponges are filter feeders. So if there's a lot of particulate in the water, they can grab a lot of food and grow. And this is a really interesting site because you knew absolutely nothing that was living on Independence was any older than 65 years. You knew the exact start date of when this whole ecosystem could have begun. And it was a really interesting story to see from a historian's perspective, from biologist perspective, coming together to write this continuation of what had been, you know, maybe the kind of story you've heard before of a military ship going off, serving historically and laudably in the war effort, and then being done with its life. So I love the story of USS Independence and just always will. My next discovery that I want to share with you is one that maybe you've seen in the news a little bit, but I want to set the stage. So we're going to come back to California, off the coast of California here. San Francisco is in the top of this map. LA would be down below, out of the corner of it. We're looking at Monterey, California, and the Monterey Bay National Marine Sanctuary. This is a protected part of America's waters, set aside because there's special ecosystems and habitats and special recreation areas to enjoy in this area. Monterey Bay protects all kinds of different animals. And like all of the sanctuaries, there's still a lot left to explore, and there's a lot of questions still left to answer about that. Now, I want to draw your attention, though, to the lower left-hand corner with that kind of wedge in there that says Davidson Seamount, and that's what's blown up here on the side of the image. Davidson Seamount is an underwater volcano off the coast of California. It hasn't erupted in something like 17 million years. We'll check that one on whether it's exactly 17, but it is an extinct underwater volcano, but a very, very large feature right off the coast. This is an area that a lot of different research teams have visited over time. They've been interested in the deep sea corals that grow there. These are massive animals and big vibrant reefs that, instead of using sunlight, capture all their food by filter feeding. So they grow very slowly, but do many of the same things that shallow water coral reefs do: support other animals, build habitat for baby fish to grow up into big fish that are important to fisheries. So there have been many interesting questions around Davidson Seamount. And we got the chance to take our ship and our ROVs there a couple years ago. As we were exploring down along the coast, along the southeastern corner of Davidson Seamount, if you've ever drawn a mountain, you kind of know that like maybe you just draw a mountain like that, but usually there's like other hills and other smaller mountains around. So we were down off that southeast corner at some of those other smaller mountains near Davidson. And right about the end of the dive, we came upon something pretty magnificent. Not one, not two, thousands of these brooding octopus. They look like little bowling balls. These are Musoctopus robustus, which is an inkless deep sea octopus. And they are upside down in this posture because they are brooding eggs. They are protecting clutches of eggs. Now, there's only one other site in the world where this behavior has ever been seen, and it was down off the coast of Costa Rica. So as we went in to investigate, we started to see shimmering water coming up out of the cracks. And this shimmering water in between these rocks, we were able to get a temperature probe onto and realize that that water is warm. So what we, as explorers, with our collective experts all together, realized is they may be kind of incubating these eggs in warmer water down on the seafloor. Now, warm is not like balmy jacuzzi water. It's just slightly warmer than the water that's about 40 degrees all around you. But anything warmer than 40 degrees, I'm sure, feels very warm on the seafloor. Now, this discovery was a couple of years ago. It was right at the end of our season, and we were so bummed that we couldn't stay out and explore this feature more. It got picked up in a lot of news. Maybe you saw it online or on social media, but we planned to go back. So this last year, we returned to the octopus garden and got to be explorers another step further, ask some more good science questions. We left behind some data loggers to understand the temperature and the chemistry of the water in the area, not just at the moment where we were watching, but how does that change over time? How does that change over years? The octopus are still there. Biologists have told us that some of these octopus brood for several years at a time. So it's a very long time to be sitting in one place defending your clutch of eggs before those octopus move off into their own life. But just a fascinating discovery that we continue to really have more questions than answers about. So last year we had installed these loggers, we had seen the octopus, we had set up that experiment, and we just had a little tiny bit of time left in the dive. It was the last dive of the last day of the expedition. And we said, you know, got a couple hours left. There's another little mountain off to the side a little bit. Maybe we could go over there and see what's happening on that mountain. Maybe there are more octopus. That's kind of what exploration is like, right? You use your clues. You say, if, okay, these octopus seem to be in this area, they like that. Let's be as efficient as we can, and let's get over there and discover what's happening over there. So off we went into the sand. Now, this is what the sand looks like at the bottom of the ocean. Kind of brown, kind of gray. And as you're moving across like a large sandy area, this is what you might tune into and see on Nautilus Live. Now, there are all kinds of interesting things here, bacteria, small animals, but mostly we were just covering ground, trying to get to this other hill. We were very surprised by what came up next. And this is the last discovery I want to share with you, because it was this discovery I never expected we were going to make at this moment. So as we are trucking along the mud, all of a sudden, kind of off in the distance, you start to see something on the seafloor. And there start to be fish and octopus all around. And as we pass over this, we realize, and the lights come up on, a whale fall. Now, a whale fall is when a whale dies and sinks to the seafloor. You can imagine the dinner bell ringing. If you're an animal down here that usually is just scavenging and cleaning up other things, something as big as a whale showing up as a meal is maybe the event of the year for you, really. And so we've found this whale, and we know it's a baleen whale. So at this moment, like, everyone in the control van is kind of just yelling, really. We're just like, what is it? Stop. And everyone starts throwing their questions out there. So one of the things I love working on this team is everybody's ideas are good. You start to like ask questions, gather information, and then it's sort of like clues. You can start to like weave in on answers a little bit. So you see there are octopus and fish all over scavenging this whale. This also was late in the year, so talk about like spooky Halloween, fantastic creepiness. We were able to spend the little time we had left on this dive exploring this, because it's very unique to find a whale like this, or a whale fall like this, especially when it is still being eaten and still being digested. As you can imagine, with so much of the ocean floor totally unexplored, it would be very hard to pinpoint, basically impossible to pinpoint where the next whale fall will be. Researchers have studied whale falls by intentionally sinking whales that have washed up dead on the shore as a way to dispose and naturally recycle them. But this is a unique chance to look at one that was just discovered right in that moment. So we learned a lot of cool things, and I love this discovery because I learned a lot of cool things. Turns out there are special worms called osedax worms, and osedax worms only eat bones. And the osedax worms are what look kind of like fuzzy hair, right, on the skeleton that you can see there. They drill in and they actually digest the calcium and the lipids and the amino acids that make up all of these bones that make up a whale. So this was just a fantastic discovery, and it really reminded me that you never know what you're going to find next. We didn't plan to find this. In fact, we were just kind of like moving along, trying to get to the next target. So being an explorer is about staying curious and just always staying ready. Because if we knew what we were going to find somewhere, we wouldn't have to go. Instead, we go and we let the amazing drama that is the planet just reveal new scenes and reveal new discoveries to us. Now, before I wrap up with questions, and I cannot wait to see what questions you have for me out of this, I want to thank my team. We call our team the core of exploration. And I have the chance to talk with you today, but none of this work would be possible without the teamwork that goes into all of us planning and executing and safely creating missions just like this one. So our core of exploration are really set up to be role models, and they come from so many different pathways, from all over the world, from all over the country, from different types of school. We bring people to sea with us as soon as they're in community college. Undergraduates, graduates, we bring educators to sea with us, technology specialists. There are lots of ways to be an explorer if you would like to do something like this in your future. Explorers are scientists, they're engineers, they're technology specialists, they're storytellers. So if you're an educator or a filmmaker, and our professional crew who keep us safe on our ship. If you want to have a career traveling all over the world, certainly consider being a mariner. That is a great option for you. And if you want to meet some of these folks on this screen, like Robert or Bryce, Mike, Pavel, and Lydia, you can meet our team by checking out nautiluslive.org. We've set up a variety of team pages. So if you click on the team, you can check out all the different types of explorers that come to sea with us, all the people we need to safely make a mission happen. There are videos that will introduce you to what like a day in the life of this person is and what their work looks like, and some of the different types of pathways, whether or not they were trained in a technical college or whether they went to school for an advanced studies degree, how you can become someone just like this, or if you have a passion somewhat like that, how you could take that passion and turn it into the career you're dreaming of. So I want to thank you for letting me share some of my favorite discoveries. I think the thing that is maybe the most exciting about my work is that we're never ever going to be done. We have so many great pieces of technology and new tools to explore the ocean that the generation of explorers coming up right now will be the greatest explorers the world has ever known. They will explore more of Earth than everyone else combined. And I'm just excited to be part of that and to help see where your curiosity and your dreams and goals take you. If you want to come along with us and get started on your training as an explorer, tune in to nautiluslive.org. We'll be launching our expedition season this year. And there are thousands of videos and photos like the ones I've shared with you today for you to explore in addition to those career pages. So I'm gonna stop sharing my screen and come back, and we'll kick it off with the first question.
Thank you so much, Megan. We all learned a lot, and we got some great questions to ask. So I guess we'll start right where you left off, which was people want to know what would you recommend to study, tasks, skills, activities that you'd recommend to build on or learn to become an explorer?
Ooh, really good question. Okay. Um, as far as what do you want to study, I think it is really what lights your brain on fire is a really important thing to study. Explorers come from many different perspectives. You can be a scientist, like a biologist, a chemist, a geologist, a physicist, and become an explorer. You could be an engineer. We have mechanical engineers, electrical engineers. Some schools even have ocean engineering, which focuses very much on building tools and technology to withstand the tough environment of the ocean. We have broadcast technology specialists, so you could be a filmmaker or a satellite technician. You know, what combines our team is really that everyone has an insatiable curiosity. Everyone is interested in learning more, and they're really good teammates. A ship is a small place to work and to live. So as far as skills that you can build to help you become an explorer, being a good communicator is really important to talk about like what you're trying to accomplish in a project, how other people can help you when you run into problems, working on those mitigation skills. How can we get everything we need to done with a set amount of time and priorities? Those things are more important than you would think. I didn't get onto Nautilus and have to pass like a biology test of like how many fish I could name, but I'm very sure that had I got onto Nautilus and not gotten along well with others and not been able to express my ideas and my curiosity, that would have slowed up the path a whole lot more. So certainly take those STEM classes, take those math classes. Don't be deceived to think that all these classes are easy. All of us have struggled. All of us have gone through those things that are difficult for us. But we have a passion to get to the other side, and that curiosity and that drive to want to do work like this certainly carried me through some hard classes and some challenging times, and they can carry you there too.
Okay, so that's all great. Tatiana asks, what other jobs did you take on your path to get where you are?
Oh, Tatiana, I've had so many other jobs. Great question. I have done everything from, I professionally drove and fixed boats for a while. I was a freediving coach for a while. I was a research assistant. So really when I was going down the science path, I wanted to do science that involved scuba diving. So I became certified as a scuba diver first and later a scuba diving instructor. Gosh, I was a football referee, was my very first job. I also, gosh, I've had all kinds of different jobs along the way. I think, you know, an important thing to know there is like, there's something to learn from absolutely every job that you have. Whether or not you have this vision that like, the first job I will get is marine biologist who saves the oceans. That's not probably the job title that you will have on that first job, but there's something that you can learn from every job along the way. So my first job actually in science was quality checking somebody's notes. So I had an Excel spreadsheet and a notebook of written notes, and I had to like check what this line was and make sure that it was the same line on the computer. And I did that for hours and hours and weeks and months as my foot in the door. But it helped me get to know researchers. It helped me understand that attention to detail and, you know, willingness to stick to something is important in science. So, you know, don't be afraid to take the job where you know you'll learn something. If you have a job you're not particularly keen on, maybe figure out what you can learn from it and then use it as, you know, your next launching point to go after the next job.
Awesome. Okay, so we had a couple on seasons and dry docking. So Mark wants to know if the Nautilus is dry docked right now and when the next expedition is. And I personally want to know how do you understand what the season, like how do you guys form the seasons?
Oh, great question. Okay. Mark, yes, Nautilus is currently in dry dock. Ships, kind of like cars, go to the shop. Ships also need mechanical work like that. So we have a really exciting development right now that we've been working on, installing a new engine in the ship and refitting some of the spaces. We just designed new control rooms for Nautilus during this off-season time. So during the time that we have been not broadcasting since sort of November. So those projects are ongoing on Nautilus right now. In light of the COVID-19 global pandemic, our season plans are in consideration right now. Our biggest priority is making sure our team is safe to send to sea. So our schedule right now, we've considered and continue to consider a few different kind of like sliding landscapes, and then working with groups like the CDC and the Coast Guard to understand when and how it will be safe to go to sea again. But we are planning our 2020 expedition season to launch sometime this summer, we hope, and then continuing into the end of the year. So stay tuned for live dives on Nautilus Live a little later this summer, but then all throughout the fall as well, we hope. So how do we make a season is also a very good question. If 95% of the ocean is unexplored, like you learned today, you could pretty much throw a dart, like at a map. It would hit the ocean, likely, because the ocean is most of the planet, and it would likely hit something that's totally unexplored. We want to be efficient and prioritize things that scientists are interested in. So every few years, we host a big workshop where specialists in whatever their field of science are, archaeologists, chemists, geologists, biologists, can write in what we call a white paper, which is like a proposal. It says, if you could have Nautilus and take it anywhere in the world, where would you take it and why? What is unexplored? What do you want to do? And out of those workshops, we probably have decades of work that we could do. So we start to get those ideas together. We combine people's different interests together. So we look at areas where multiple people are interested in. Maybe that's a mountain range underwater that's never been mapped, and also nobody knows what animals live there. Or there may be, a particular piece of maritime heritage, like a shipwreck in a approximate location that also has something interesting happening with the ocean mixing and the ocean chemistry. So we prioritize those lists out. Then we look at our funding each year, where we're starting our season from and kind of where we're going in between. And we start to make like a dotted line map of, we'll start here and we'll work our way north, southeast, or west, wherever, and then connect it back in together into about, we go to sea 5 to 7 months a year with Nautilus.
Wow. So are all the scientists and all the staff on there for all 5 to 7 months?
Good question. We are not. A 5 to 7 month expedition season has somewhere between 12 and 15 separate expeditions inside. So one expedition would be like visiting Monterey Bay National Marine Sanctuary and doing the research tasks they have there. So an expedition itself is usually like 1 to 3 weeks long, and a team will be on board for that. Some people stay on for multiple expeditions back to back. I like to sail about 2 months a year. I used to have jobs where I went to sea a lot more than that. When I go to sea less than that, I'm always like, hungry for more. But about 2 months a year in total out of those different 1 to 3 week chunks together is a good pace for my life right now.
That's awesome. That's amazing. So these next questions are going to get into the actual work you guys do. So Peggy wants to know, since there's no light at the depths that you have the ROV traveling, does the sudden introduction of light affect the sea life? For example, where the octopus is startled by the ROV?
Yeah, really good question. The light is new. So certainly we know there are some species that avoid ROVs, that will swim away. Using different sonar techniques, you can actually sometimes see that small groups of fish will move away from the ROV. But there are also other animals that are attracted by it, that come to hunt in the light, for example. Or so the octopus were not startled. They did not get up from their nests at all. Another factor to think about is, an ROV is it's a very strange thing to have encounter your home. If you're a sea creature, it is bright. There's sound, there's electrical pulses to it. So in that same way, it's really hard to kind of tease out, like, are animals liking or not liking the light? Are they liking or not liking the electrical impulses? We've certainly had sharks come right up and kind of like bump right into Hercules in the past. Check out those videos on nautiluslive.org if you're interested. And we can say, it's likely those sharks are using their electrical senses and coming to investigate what this, vibration and electrical frequencies of the ROV being nearby are. But it's really hard to say. So certainly some animals run away. We know we're not getting a perfect look at who's there in every habitat, but we don't know of any, lasting or permanent damage or impacts from the light. Good question, Peggy.
Awesome. Eliana asks, have you guys ever gone in discovery pods similar to the robots you showed? And
yeah.
Dove down deep with yourself?
Yeah, good question, Eliana. I would love to. I have not. So the deepest I've been in the ocean is 211 feet, and I was on a specialized scuba dive using special equipment to do that. So I have not made it more than 211 feet into the ocean, but would love to someday be in they call them HOVs, human occupied vehicles, like a submarine. And I think it would be really exciting to go down to the seafloor. One of the things that's challenging is if you send people down into the seafloor, it takes a long time to get down to the seafloor, and it takes a long time to get back up to the ship. So you spend a lot of your day just kind of like riding the elevator up and down instead of hanging out on the seafloor. ROV Hercules doesn't need to eat or sleep or go to the bathroom. So once we put Hercules down on the seafloor, our longest dive was more than 3.5 days that we left him down there. And our teams took shifts and traded out, so we stayed rested and fed and able to take breaks up in the control rooms. But that meant we could spend a lot more time on the seafloor. So I will look forward, even if it is less efficient, to getting into submarine, and maybe you can come with me someday.
So Mark wants to know about the USS Independence, a couple questions. So he wants to know, did it have any lingering radioactivity on it?
Yeah, good question. When it originally returned in the 40s, it did. It was used as a decontamination practice site. So the Navy was actually investigating how you could decontaminate a ship. And that work was done. There's a lot you can read about that period of time. Operation Crossroads is just a fascinating piece of American history. So I'd really encourage you to check it out in that site. We used protocols to make sure that the ROVs were safe as far as the samples that we collected and the protocols for using those. We had several researchers on board that's their specialty when we went there. But there is certainly not anything you imagine like the cartoons where there's, glowy light coming out from around it. It's been a long time.
So you mentioned you could pick a spot on the map and just point to it anywhere, and it's probably not been discovered. So what's the choice like process to pick the spot you guys go discover next? Is it as simple as pointing to a map, or is there some method to it?
Yeah, it is not that simple. We work with a lot of really great partners that help support and also help fund expeditions. Our expeditions are made possible largely through federal grants. So thank you to all the US citizens tuning in. We believe that understanding America, including the parts of America that are underwater, is important. And so the NOAA Office of Ocean Exploration and Research is one of our primary expedition partners. So we also work with partners like the National Marine Sanctuary System. And so that means, we decide we're going to go to one of their set priorities, like a national marine sanctuary. And then we work with the staff of the National Marine Sanctuary to say, like, out of all the things that you don't know about your sanctuary, what do you need to know in order to do good work? For the sanctuaries, they have the charge to manage and make responsible use of these oceans near our coastlines, and that are special places for cultural reasons or ecological reasons. And so you need good information in order to make good management choices. So we work with those partners and they say, we'd really like to make a map of this area of the sanctuary that's never been mapped. Or there's a series of mountains over here that we don't know what kind of animals live in the sanctuary in this area. Our priority would be to go investigate that area. So we really work closely with a lot of different scientists who then, once we go from sort of big square drawn on the map of where we want to go, to then like narrow in and narrow in and narrow in until you have a goal for a dive to say, we're going to fly the ROVs up this ridge line and see what we can see along this area and collect samples of anything that we think is new. That would be kind of a dive level target, all the way from nothing is known about this area. Where do you start?
That's awesome. Well, everyone, we have about 2 more questions that came in, and just kind of quick ones. So how many shipwrecks have you seen, and like what are your favorites? Are they a common discovery that you find across the seafloor?
Yeah, good question. There are the UNESCO, the UN estimates there are 3 million shipwrecks in the ocean yet to be found. So there are many more shipwrecks out there to be discovered, is the first answer to that. I have personally worked on the expedition of just a few, but Nautilus has, if you go to the website and you search down to the bottom of expeditions, you can actually filter by maritime archaeology and heritage and pull up all the expeditions and all the shipwrecks that we've discovered. In our early days of our organization, we did a lot of work in the Black Sea, which is a place that had a lot of ancient shipwrecks, which are incredible. We're talking couple 1,000-year-old shipwrecks that are preserved in the anoxic, so low oxygen conditions of the Black Sea. That's how I first found out about Nautilus Live, is I actually watched Nautilus discover an ancient shipwreck by tuning into Nautilus Live. So anybody out there who's really passionate about that, know that it can light off a fire and change your life and change the pathway that you're on. They're not a super common discovery for us, but 3 million shipwrecks left to find in the world. You never know.
Wow, that's amazing. Hey, well, we're running out of time, so I just want to say thank you. Thank you to everyone who participated. This has been awesome. Your questions were amazing. And yeah, if you want to learn more, nautiluslive.com, correct?
.org, nautiluslive.org, and you can send in more questions there and find answers to maybe a lot of your questions as well by checking out the gallery features and the team page.
Perfect. And we just want to say from AltaSea, thank you guys for joining us. And we have a contest going on right now. It's called Project Blue. It's an art contest for students of all ages, art, writing, poetry, songs, you name it, whatever creative outlet you want. This week's theme is, let me get it right, it's ocean exploration. What did Hercules, the Nautilus's remotely operated vehicle, find on the seafloor? And you can find out a lot of information on nautiluslive.org, or rewatch this live chat. It'll be up on altasea-project-blue.org/live-chats. And thank you guys so much for joining us. Thank you, Megan, so much. This was awesome.
My pleasure. Thanks for all the great questions, and thanks for tuning in, everybody. Have a great weekend.